Welcome to the CTFscope. CTFscope is for simulation and visualization of a contrast transfer function. This is one of the software in the Landyne series. You may download the Landyne Suite on the screen. In this video, I will introduce new components. You can start the Landyne launcher here. And this is the CTFscope. The CTFscope is for you to simulate and visualize contrast transfer function in 1D curves and 2D map. It can apply to basic parameters like high tension, the sphere aberration coefficients, and also this is temporal and spatial damping envelope. You can put the temporal and spatial damping envelope on or off. This is a change of the focus. You can use under focus or slightly over focus, and also will provide a marker for you make a measurement. So here are the graphic menu here. First one is for you to load the electron microscope parameter you saved before, and this is if you put a new parameter in, you can save them, and this of course to activate the 2D map. And this one is for the basic control dialog box, and this one is for provide a calculation of a focal thread for this one. So this parameter will go to here. This is the simulating the PM object aperture, and when sample or the image high order aberration parameters, astigmatism, chroma, and star, the loop. So for aberration-corrected microscope, you had to use those parameters make a simulation. This one is show the curve, save the curves, and this one for you to save the 2D CTF map. And this is for you to load image, and then you can do two kind of processing. Use a CTF or a CTF absolute value. And here are options for you change the interface of the whole. Make a graphic bar in, on or out, or change a different appearance. In help that you have current drive and also serial number of your drive, which you can use these numbers to obtain a license for this program, because some of the function need a license, but for the basic operation you don't need a license. And this is show you the license log. Now let's check that how the basic parameter affected for the CTF curves. That you can change the high tension. If you have a microscope for 300 kilowatt, you can change it here to 3, and you can see that both of the 2D map and 1D curves change. If you change the sphere aberration coefficient, some microscope you can check 1.5, you can see it changes. Of course, the CS, the smaller the resolution could be higher. So let's go back to 2. You get this parameter fill in, can use this dialog box and fill the CC parameter, and the rest is 3, and go calculation here, and get this value here, and you can put it here. This is the beam semi-angle, the beam convergence semi-angles. Let's see if this is changed to 2. You can see the curvatures. Limited the information. The information limited is become smaller. So let's bring back to here, back to. You can show this 2 curve here, or you hide them, and you can make the measure the. See here, it gives you the G value, also the resolution in direct space. If you change the focus, you see the curvature change. For certain input parameter, you can set the extend search focus directly in the CTF here. So the focus, it will automatically calculate the curve and make the mark to show you. There are different ways to show the 2D map. This is the pseudo color one, default choice here. You can use 3 difference of grille scale. For the first one, it shows you like similar the pseudo color, but change it black and white. And this is inverse, so it just changes black, white, black change to white, and white change to black. And this is from black and to white here. This shows black here, and to both 1 and -1 as white. The 2D colors can have the marks too, but only when this 2 value here, the zoom value here, are the same value. Otherwise, if you change this one, the marks will disappear. You can adjust this one, to make them the same value. Then you can apply this one again. So it shows this here. And if you change the marks, they show you where it is simultaneous. For tutorial purpose, we provide also point spread function 1 and point spread function 2. The function 1 is a Fourier transform of the, so you can push here, and you see this is the function. We'll show you with the image and how this point spread function works. That will be here, the processing 1 and 2. And for the point spread function 2, you see it's much sharper. It means that if you know the CTF curve, and you can reprocess your image with the value or great absolute value, you can have a sharper image there. So let's bring this back to CTF form here. So now let's try to use any image. Here we have one. So you can click on the image and drag it into this drag and drop box, and you have the original map, and this is the map you bring in. So now let's see how the point spread function 1 works. So that's you get original image convoluted with a point spread function 1. And this image is a little blur, but it catches the feature of the image. And now we try to number 2. Yeah, clearly it shows a little bit sharper than the point spread function 1. So this is how, of course, you can bring in different image and have a different values here to do the processing for tutorial or purpose. So now let's see a drift effect to your image. So we have here, or we can bring the zoom a little bit higher so you can see it. And maybe we change the speed to 0.2 to make it more clear. Yeah, so you can see it's damping here in this direction. Of course, if you change the angles too much to 45 degrees, and you can see the damping also changes to the. If you now do the image processing, you can see how the drift effect to your image. You should compare this one without drift. More effect on the image. Yeah. So now you see that the drift causes your image. And now see the, yeah, it's a little sharper, but it's still better than the the pattern before without the drift. So put it to 0. We can also simulating the aperture effective to the image. So we can apply that's with the surgical focus, and you can do the processing now. Yeah, that is the image with the aperture only cut off at the surgical focus. And you can see, because here flip over and down is the same, so when we choose the spread function for find spread function 2, that image is no changes. Now we show use a CTFscope to calculate some of CTF map compared to the published results. Example 1 is experimental result, simulation result, published software, extender CTF. And we want to simulate for the image like this. So the next one is defocus 0, astigmatism is 308. That is what you see in the map. Third one is defocus 0 and astigmatism is 85. That's what you see in that image. The last one is defocus is minus 404. That's the image. This is the second example from the paper here in Journal of Analytical Science and Technology. The figure 4 and this one. You can load. Is called this one. All the date here and here. This is no use. We had to adjust the zoom ourselves. 0.3. And in the programs they used grayscale, this one. So you can see this figure engraved with the papers I showed you before, the pattern, so exactly the same. The CTFscope works well. Can use as a tutorial purpose. You can apply to your aberration-corrected microscope. And a paper about this CTFscope is submitted to Microscopy today, and hopefully it will appear on the magazine in December this year. Thank you so much for watching the video.